Yeah, this video is about testing a population proportion, and in this case we know that we are interested in the parameter P, probability of success or proportion of successes in an entire population, and usually that's an unknown parameter. So to find out something about it, we collect data. Basically our data, the sample size, how many measurements we collect, and x is the number of successes, and if we take x over n we get p hat, which is the proportion of successes, and that's usually our estimate of p. So p0 is the target value. We want to know whether p is equal or not equal to p0 or larger than p0 and so on. So another value we need is alpha, which is called the significance level. Of course we need usually big alpha between 5%, 10% or so on. So our test now, again, the structure of the test, we have same thing, P null hypothesis, we pick P equal P0, and the alternatives, there are three possible alternatives. Upper tail test if P is larger than P0, lower tail test if P is less than P0, and two tail test if P is not equal to P0. And our test statistic in this case, again we deal only with large samples. We don't have to deal with small samples because the tests are quite different and beyond the level of this class. So we take p hat minus p0 over the point estimator of over the standard error of p hat. And remember, the standard error of p hat is pq over n, but under the assumption that, let's assume h0 is true, then we say p0 q0 over square root of n. So remember here it's p0 q0, which is this value here, over the square root of n that we use. And then our critical value is going to be z alpha if it's an upper tail test, since we're dealing with a large sample. It's going to be negative z alpha if it's a lower tail test, and it's going to be z alpha over 2 and negative z alpha over 2 if it's a two-tail test. And so we reject if h0 in the first case, if z is larger than z alpha. We reject h0 if z is less than negative z alpha if it's a lower tail test, and we reject h0 if z is larger than z alpha over 2 or less than negative z alpha over 2 if it's a two-tail test. Now we had the same thing before. So again, if now instead of mu, and you've seen this before, it's going to be p. Okay. So if I change this, I change that to p greater than p0. If this is my alternative, it's going to be the same graph we had for mu, and this would be our rejection region, this would be our non-rejection region. If it's a lower tail test, it's going to be p less than p0, and again my critical value would be in the lower tail. This would be my rejection region, this is my non-rejection region, and if my z is here, I would reject. If it's up there, I would say don't reject. And similarly, if p is not equal to p0, then it would be a two-tail test where my rejection region is in both tails, and here is my non-rejection region. Okay, so that's the same thing, doesn't change. Again, so if the observed value z is in the rejection region, we reject. If it's not, we do not reject. Same conclusion. Now the assumptions for this test. So first we need our sample to be large for this to be true, and that means same condition we had before, np and q both should be greater or equal to 0. Okay, because when we apply it, we check np hat and then q hat, and the sample should be random. So here's an example. Say we want to test the hypothesis that p is more than 0.1 or 10% for the sample data when n is 200 and x is 26. So suppose this is like testing the favorable rating for, say, brand A of coffee, and we picked a sample of 200 and 26 indicated preference, and we suspect or we are interested to know that whether P is more than 10%, because we would really, that would be helpful for our marketing maybe campaign. So we first estimate P hat, which is x over n, and turns out to be 13%. So in my sample, I have 13% expresses preference for this brand. I want to know whether in the whole population of the hundreds of thousands who buy my product, P would be maybe more than 10%. Okay, so in this case, we need to take into account many factors, alpha and the standard error and so on. So we set up the problem, P equal 0.1 versus P is larger than 0.1. Oh, this is our test statistic. I'm going to substitute in it. So my P hat is 0.13, P0 is 0.1, and then here square root of P0 Q0 over n, so it's going to be 0.1, 0.9 divided by 200. Do all these calculations and gave me 1.41. What's my critical value? I'm dealing with an upper tail test. There is no mention in the problem what alpha is, so that means I have to use the default value, which is 5%. So my critical value then would be Z alpha, which is 1.645, and the graph for this would be again the first one here. So this is going to be 1.645, and the value I obtained was 1.41. 1.41 falls down here, which is less than this value. So I'm not in the rejection region. So my decision is do not reject H0. So at 5% significance level, there is insufficient statistical evidence to conclude that P is greater than 10%. Now here's an exercise. Is the large sample assumption satisfied here? Well, we have to check n times P. 200 times 0.13 would be 26. That's fine. And NQ, of course, would be, because Q hat would be 0.87. Yeah, that would be satisfied. So the answer is yes, but please get those values and test it. Okay.